A. Writing pad is not working on this laptop, so maybe you will get some message. Okay. So if something is not readable, you can ask. Let A and B be two square matrix. B square matrix square matrices of the same order. uh, Same order. The matrix A is said to be a similar than matrix A. Matrix A is said to be similar to a matrix B to the matrix B if there exists invertible matrix P, if there exists an invertible matrix P matrix P such that this A is equal to a P inverse BP, or A is equal to a PBP inverse. Okay, either you multiply with the pre-inverse pre-multiplied or either post-multiplied. Okay, but if you pre-multiplied with the P inverse, then post-multiplied with the P. Okay, so A is equal to a P inverse BP or A is equal to a PBP inverse. So this implies, now if you will multiply now this first equation, so this A is equal to P inverse BP. If you pre-multiply both side by a P and post-multiply by P inverse, then what you will get? If you will pre-multiply both side by a P, then you will get PA is equal to a BP. Or in a second equation, if you post multiply by a P, then you will get AP is equal to PB. Okay. So now if you multiply this first equations, post multiply by P inverse, then you will get PA P inverse is equal to B. Okay, so B into P into P inverse, so P into P inverse, that is identity to B, you will get a B matrix. Or in the second one, if you will pre-multiply with the P inverse, then you will get P inverse AP is equal to a B matrix. B matrix. So what does this mean? If A is a similar to a B matrix, so B is also similar to a matrix. Okay. So if A is similar to a B, then B is also similar to a. So only these are the requirements for a similar matrix. Two matrix, square matrix of same order are said to be a similar matrix. It will satisfy these requirements, these equations. Now let's take an example. Is there should exist an invertible matrix P such that PA is equal to BP or AP is equal to a PB. Now examine whether A is a similar to a B or not. So A is similar to B or not. what are the A and B matrix? Here, number first part, A matrix is a 1 0 0 1. B matrix is 1 1 0 1. And second part questions, A matrix is 5 5 minus 2 0. B matrix is 1 2 minus 3 4. Okay, so now they are the similar matrix. You have to examine this. So they will be a similar matrix if there exists an invertible matrix P such that PA is equal to a BP. Okay. So now let's examine whether they are the similar matrix. So let me assume a P matrix. P, it is a A, B, C, D such that PA is equal to a BP. Okay. Now, if this is the invertible matrix, then this A and B are the similar matrix. We have considered a P matrix such that PA is equal to a BP. Now, what if this P is an invertible matrix? Then you will say that A and B are the similar matrix. Now, find out this P matrix. So this implies now P is A, B, C, D. What is the A matrix? The first part, the part number 1. What is the A matrix? Unit matrix, order 2, 1 0 0 1, equal to a B into P. What is a B matrix? 1 1 0 1. Okay, into P matrix. P matrix is A, B, C, D. If you will further simplify this, what you will get, matrix into identity matrix, so you will get the same matrix again, A, B, C, D. And on the other side, and you will multiply first row with first column, you will get A plus C, and then B plus D. The second row you will get C and D. So this implies, you know, if you will compare both sides, so you will get A is equal to A plus C and B is equal to B plus D. So this A cancel out and B cancel out. So this implies C is equal to 0 and D is equal to 0. Okay. So therefore, what is the P matrix?
A, B, C, D.
Writing pad is not working properly on this laptop. Yeah. So therefore, P is equal to A, B, C is 0, D is 0. Now, is it an invertible matrix? Yes. Is it an invertible matrix? P inverse exist करेगा? Yes. बताओ.
No sir.
Because
वो उससे infinite हो जाएगा ना.
sorry, because it is a singular matrix. Determinant इसका जो अब 0 आ जाएगा ना.
Yes sir.
So which is a singular matrix. एक रो इसका जो अब आपके पास 0 है, so इसका determinant 0 आएगा. So which is a singular matrix. Okay, so if it is singular matrix, so it means it is not invertible. So therefore, there does not exist an invertible matrix P such that PA is equal to a BP. ऐसी invertible matrix exist ही नहीं कर रही है. Okay, so what does this imply? A is not a similar to a B matrix, or B is not a similar to a matrix. Okay, so this implies A is not similar to B matrix. Got it? Is there any doubt?
No, sir.
No, sir.
Now, next is the diagonalizables. I hope now you can check the second one also, na? Okay, the second example you have to try.
सर वो क्वेश्चन लिखा है.
Sorry. Okay. Yes.
Yes, sir.
Okay. So next is the diagonalizable matrix. So a square matrix is said to be a diagonalizable if it is similar to a diagonal matrix. Okay. So a square matrix is diagonalizable if it is similar to a diagonal matrix. If it is similar to a diagonal matrix. Now, what does this mean? That is, there exists an invertible matrix P. That is, there exists an invertible matrix P such that P inverse AP is equal to a D, some diagonal matrix, where D is the diagonal matrix. Where D is a. Now, can you guess what should be the D matrix? अब डायगोनल मैट्रिक्स निकाल सकते हो, ये डी मैट्रिक्स होगा क्या?
यस सर, निकाल देंगे सर. वो पी को ऐड कर देने का ABCD ए से
क्या?
मल्टीप्लाई. पी को मतलब फाइंड करने का पहले उसका अगर डिटर्मिनेंट 0 आता है.
अरे यार इतना. तो अभी आपको दिख रहा है कि ए जो है वो डायगोनलाइजेबल होगा इफ इट इज सिमिलर टू अ डायगोनल मैट्रिक्स डी. सो हियर ए एंड डी आर द डायगोनल मैट्रिक्स ना. ओके ओके, वो कॉन्सेप्ट पीछे थ्योरम नहीं लिखा, तो ये काम ही नहीं कर रहा है सही से. रिजल्ट लिखना भूल गए पीछे. we have one theorem here, says that the similar matrix have the same eigenvalues. Similar matrices have the same eigenvalues. And now for similar matrix, I will write here similar matrix A and B. So similar matrix A. And further, if X is the eigenvectors, further if X is eigenvector of A matrix corresponding to the eigenvalues lambda, to lambda, okay, then what should be the eigenvectors of the B matrix? Because A and B have the same eigenvalues. If lambda is the eigenvalue of the A, then lambda is also eigenvalue of the B. ये लिखा ना हमने ऊपर कि similar matrix have the same eigenvalues. But what about the eigenvectors? If X is the eigenvectors of A corresponding to lambda, then what about the eigenvectors of the B matrix corresponding to a same eigenvalue lambda? Then P inverse X is the eigenvectors. Is the eigenvector of B corresponding to the eigenvalue lambda. Of B corresponding to eigenvalue lambda. Got it? A similar matrix have the same eigenvalues. Now, using this concept, now can you guess what should be the D matrix in a diagonalizable matrix? So A is a square matrix is diagonalizable if it is similar to a some diagonal matrix D. So A and D are the similar matrix, and the similar matrix have the same eigenvalues. So whatever is the eigenvalue for the A, D also have the same eigenvalues. Now let lambda 1, lambda 2, so on lambda n, they are the eigenvalues of the A. Then what should be the D? Yes? बताओ. Hmm? D is the diagonal matrix. Diagonal matrix की eigenvalues क्या होती हैं? हेलो? अगर कोई डायगोनल मैट्रिक्स है उसकी आइगन वैल्यूज क्या आएंगी? आता है नहीं आता है, रिप्लाई तो करो. प्रॉपर्टी लिखा है पीछे हमने जो वो डायगोनल मैट्रिक्स अपर ट्रायंगुलर्स लोअर ट्रायंगुलर्स देयर आइगन वैल्यूज आर देयर डायगोनल एंट्रीज. डी अगर डायगोनल मैट्रिक्स है उसकी आइगन वैल्यू ए की ही आइगन वैल्यूज होंगी बिकॉज ए एंड डी आर द सिमिलर मैट्रिक्स. तो डी मैट्रिक्स की डायगोनल एंट्रीज आर द आइगन वैल्यूज ऑफ द ए मैट्रिक्स. गॉट इट? हेलो, एम आई ऑडिबल? रिप्लाई नहीं करोगे तो लेक्चर में अच्छा नहीं आता ना कि आप लोग एक्टिव रहो ना. Since similar तो काम नहीं करती है ये। Similar matrices have same eigenvalues. Eigenvalues. Therefore, diagonal entries of the D are the eigenvalues of the A matrix. So therefore, diagonal entries of D are the eigenvalues of A. Okay, that is D is equal to this lambda 1, lambda 2, so on lambda n. They are the interest of the 0. Where lambda 1, lambda 2, and lambda n are the eigenvalues of lambda 1, lambda 2, lambda n are eigenvalues of A matrix. Got it? The square matrix is diagonalizable if it is similar to a diagonal matrix. So it means there exists an invertible matrix P, so that P inverse AP is equal to some diagonal matrix D. So A and D are the similar matrix now, and similar matrix have the same eigenvalues. So whatever is the eigenvalue of A, D also have the same eigenvalues. Okay, and D is a diagonal matrix, so its eigenvalues are is diagonal entries. So this will be your D. Now we have a remark: if A is a diagonalizable, then A raised to power m is also diagonalizable. Remark: if A is diagonalizable, then A raised to power m, m is some positive integer, m is a positive integer, is also diagonalizable, is also diagonalizable. Okay, now can you prove this? So if A is a diagonalizable, so it means there exists an invertible matrix P such that P inverse AP is equal to a D matrix. Got it? If A is a diagonalizable. So if you will pre-multiply with the P and post-multiply with the P inverse, so then you will get A is equal to a P D into P inverse. Got it? So therefore, what is the A square? A square is equal to A into A is equal to a P into D into P inverse into P into D into P inverse. Okay, so this P inverse into P, that will become identity. So identity into D is the D. So it will become equal to a P into D square into P inverse. Na? Okay. So which implies, now if you will pre-multiply with the P inverse, and post multiply with the P, then you will get P inverse A square P is equal to a D square matrix. So if D is a diagonal matrix, so this is also diagonal matrix D square. So what does this mean? This implies that A square is a diagonalizable. So this implies A square is a diagonalizable because there exists a invertible matrix P such that P inverse A square P is equal to a D square. Okay, similarly you can find the A cube also. Guys, A square is a diagonalizable. Okay. Now similarly you can check A cube also. Is a into A square. In this case you will get it is equal to a P inverse P into if you will calculate A cube, so A cube you will get it is equal to a P into D cube, so P into D cube into P inverse. Okay, so this implies P inverse A cube into P is equal to a D cube. So it is also diagonalizables now. Okay, so hence A ki power, so therefore A ki power M, that is also equal to a P into D ki power M into P inverse. Okay. So which implies P inverse A ki power M into P is equal to D ki power M. So this implies A ki power M is a diagonalizable. Diagonalizable. Okay. So if A is a diagonalizable, so A ki power M is also diagonalizable. Okay. So now, what should be the necessary and sufficient conditions for the diagonalizability? Okay. कि हम कैसे बोलेंगे कि we have a conditions. अगर P inverse P invertible matrix exist करता है तभी वो diagonalizable होगा. तो necessary sufficient condition for the existence of P. अगर ऐसा P एग्जिस्ट ही ना करे, such that invertible matrix एग्जिस्ट ना करे, so that P inverse AP is equal to a D, so matrix is not diagonalizable. Okay, so P कब एग्जिस्ट करेगा? What should be the necessary and sufficient criteria for the diagonalizables? Okay, so a square matrix A is of order A is said to be a diagonalizable if it has n linearly independent eigenvectors. A square matrix A of order n. कोई डाउट हो रहा तो पूछ सकते हो साथ साथ में. तो मैं सीधा भी लिख सकता हूँ कि ये डायगोनलाइजेबल आपको जो ऑब्जेक्ट करना है क्या है, बट आपको कॉन्सेप्ट पता होने चाहिए. ठीक है ना, हम लोगों को जो अब क्लर्क नहीं बनना है, बैकग्राउंड में क्या है स्टोरी वो सारा पता होना चाहिए. डायगोनलाइजेबल्स if and only if, तो ये लैपटॉप here you can see this is a necessary and the sufficient condition for the existence of P. A square matrix A of order n is a diagonalizable if and only if it has n linearly independent eigenvectors. Is it clear? Okay. आपने एग्जाम्पल किए थे, मैंने आपको एक 3 एग्जाम्पल दिए थे. एक केस में, तीनों केस में लैम्डा इज रिपीटेड 3 टाइम्स. लैम्डा इज रिपीटेड 3 टाइम्स. Okay, it has no this example. ये हमने किया था. फर्स्ट केस में भी लैम्डा हैज अ मल्टीप्लिसिटी 3. तो लैम्डा के फर्स्ट केस में कितने लीनियर इंडिपेंडेंट आइगन वेक्टर आए थे? हाउ मेनी यू विल गेट द इन फर्स्ट केस? ओनली वन आइगन वेक्टर्स यू गेट. सेकंड केस में लैम्डा is equal to a 1 is repeated 3 times, you got the 2 eigenvectors. Third case में lambda is equal to a 1 is repeated 3 times and you got the 3 eigenvectors. So which one is the diagonalizable here? The square matrix of order n is diagonalizable if it has n linearly independent eigenvectors. इस केस में आपके पास जो है वो n linearly independent eigenvector आ रहे हैं. Here n is a 3 order of the matrix. थर्ड केस में, फर्स्ट और सेकंड केस में, फर्स्ट केस में आपके पास एक आइगन वेक्टर आया था, सेकंड में 2 आइगन वेक्टर्स आए थे, थर्ड केस में आपके पास 3 आइगन वेक्टर्स आए. तो थर्ड इज अ डायगोनलाइजेबल ओनली. फर्स्ट एंड सेकंड आर नॉट डायगोनलाइजेबल. ओके, कैन यू अपलोड करना भी? Okay, so this is the criteria, okay, to examine whether the matrix is a diagonalizable or not. So it has n linearly independent eigenvectors. Now we have one remark here. So then what should be the P matrix? So let x1, x2 and so on xn are n linearly independent eigenvectors of square matrix A. Then P is equal to a x1, x2, x3 and xn. Means x1 will constitute the first column of the P, x2 will constitute the second column of the P, and x3 will constitute third column of the P, and xn will constitute the nth column of the P. Now is it clear? Okay, then write on the question. Example. So that the matrix A is diagonalizable. That the matrix A, which is a matrix, first row is a 3, 1, -1, second is -2, 1, 2, 0, 1, 2 is diagonalizable. Okay, so you have to check if this matrix is a diagonalizable. अभी मैंने आपको रिजल्ट बताया, matrix will be a diagonalizable if it has a matrix, square matrix of order n is diagonalizable if it has n linearly independent eigenvectors. So you have to find out the eigenvector for this. Here n is a 3 order of this matrix. If it has a 3 linearly independent eigenvectors. Okay, अगर आपको 3 eigenvectors मिलते हैं, then this is the diagonalizables. Find out the eigenvectors for this. बताओ, निकालो इसके आइगन वेक्टर्स। क्या इसके पास 3 लीनियरली इंडिपेंडेंट आइगन वेक्टर्स हैं? फाइंड आउट करो इसके आइगन वेक्टर्स। You have to prove it is a whether it is a diagonalizable or not. So set the matrix. This is the diagonalizable. This is diagonalizable. You have to show this. So if it has a 3 linearly independent eigenvectors, then this matrix will be a diagonalizable. What are the eigenvalues of this matrix?
सर तीन वैल्यू आ रही है
सर 1 2 and 3
1 2 and 3
1 2 and 3। तो अब इसके पास
Yes, sir.
लीनियरली इंडिपेंडेंट आइगनवेक्टर्स होंगे क्या? यस, बताओ। हर एक आइगन वैल्यू के कॉरस्पॉन्डिंग अब आपको एक आइगन वेक्टर मिलेगा। You have a 3 distinct eigenvalues. Corresponding to each eigenvalue, you will get a 1 eigenvector, which are linearly independent to each other. ना जो eigenvectors होंगे वो linearly independent ही हमने निकालने हैं कि कितने eigenvectors हैं, बाकी तो उसके स्केलर मल्टीपल से आते हैं। So if eigenvalue is not repeated, then corresponding to each eigenvalues, you will get a 1 eigenvector. If it is a repeated, then you have to examine whether if it is a repeated m times, then it may have either 1 eigenvectors or m eigenvectors ना। बट यहाँ पे तो रिपीटेड नहीं है, तीनों डिस्टिंक्ट हैं, तो तीनों के कॉरस्पॉन्डिंग you will get a 1 1 eigenvectors which are linearly independent. So it is a diagonalizable matrix. Got it? Now it is a diagonalizable. कोई क्वेश्चन हो तो बेटा पूछो। कोई बात नहीं समझ आ रही हो, can ask the question. Now if it is a diagonalizable, okay, because it has a 3 linearly independent eigenvectors, you will get the 3 distinct eigenvalues. So corresponding to each eigenvalue, you will get a 1 eigenvector, okay, which are linearly independent. So you got the 3 linearly independent eigenvectors. So hence it is a diagonalizable. Now if it is a diagonalizable, then next question is find the P matrix. Hence
Sir, P matrix 0, 1, 1, 1, 0, -1 and 1, 1, 1.
जस्ट वेट, मैं बताता हूँ अभी आपको. Such that P inverse AP is a diagonal matrix. अगर वो डायगोनलाइजेबल है तो डेफिनेटली ऐसा P एग्जिस्ट करेगा एंड P इनवर्स AP इज अ डायगोनल मैट्रिक्स.
Yes.
Okay. Okay. So now for lambda is equal to a 1, what will be your eigenvectors? So you got here the eigenvalues are here, eigenvalues of A is equal to a 1, 2 and 3 na. Okay. So 1 के corresponding eigenvectors V1. What is the eigenvector?
So 1, -1 and 1.
1, -1 and 1. Yes. For lambda is equal to 2.
So it's 1, 0, 1.
1, 0, 1. सबका यही आया है, ने भी सॉल्व किया है, सबका यही आ रहा है. V3
So 0, 1, 1.
0, 1, 1. Yes. Okay. So therefore, what is the P matrix? V1 will constitute the first column, V2 will constitute second column, V3 will constitute third column. So it is equal to a 1, -1, 1, 1, 0, 1, and 0, 0, 1, 1. This is your P matrix. Okay. Then now you got the P matrix, and you can verify here also कि P inverse AP is a, definitely you will get it is a diagonal matrix ना. तो P inverse AP किसके इक्वल आएगा अगर कैलकुलेट करोगे आप?
So original matrix के इक्वल आएगा.
D के
A
इक्वल.
के.
D. What should be the D?
Oh sir, sorry, diagonal matrix के इक्वल आएगा.
D. So what should be the D?
सर वो 3, 0, सर 3, 0, 0, 0, 2, 0 and 0, 0, 1.
Sorry?
सर वो 3, 0, 0 and सर 0, 2, 0 and 0, 0, 1.
उल्टा क्यों कर रहे हो? फर्स्ट 1 है तो 1, 0, 0, 0, 2, 0, 0, 0, 3 ना.
सर वैसे भी कर सकते सर. अगर वो उल्टा कर देंगे सर तो गलत हो जाता है.
तो जहां पर फिर P मैट्रिक्स, आपने P मैट्रिक्स में फर्स्ट वेक्टर V1 लिया है ना,
हाँ
तो
सर.
आइगन वैल्यू आपकी लैम्डा है, तो उसके अकॉर्डिंगली आपको फिर जो है वो डी मैट्रिक्स लिखना पड़ेगा ना,
ओके सर.
अदरवाइज गलत हो जाएगा ना.
ओके सर.
P में आपने फर्स्ट वेक्टर जो है वो लैम्डा इज इक्वल टू 1 के कॉरस्पॉन्डिंग लिख दिया है फर्स्ट कॉलम, और बाद वहां पर आप जो है वो 3 लिख रहे हो फर्स्ट, तो फिर गलत होगा ना आंसर.
यस सर.
ओके. तो then now find the matrix, then obtain the matrix B, which is equal to a square plus 5a plus 3i. Now, can you find out this? So you get here okay. this P inverse AP, that if you will calculate, it is equal to a D matrix, and that D matrix is a 1, 2, 3 diagonal entries, and other are 0 now. Okay. Now can you find out this B matrix? Is A square plus 5A plus 3I. Okay, you try this, otherwise we will discuss in the next lectures now. Okay. Okay, you can leave the class. I will ask you in the next lectures now the answer of this B matrix.